So we have y prime is equal to -2 times x, which is -2, times x prime, which is 2, over 1 plus x squared. So if we take this -2, because -2 is x, and we square it, that gives us +4, because what happens when you square a negative, Miss Green? It's a positive, that's right. And then squared. So if we get this numerator part, that's -2 times -2, that's a +4, times 2, that is a +8, over 1 plus 4 is 5, squared, and we get a 25. So my y prime is equal to 8 over 25, and it's a rate. So a rate is always some kind of unit over time. So it will be the only rate that we see here, which will be centimeters per second. So 8 over 25 centimeters per second will be our answer for number 6. Okay, let's move on to number 8. Number 8 states y equals sine of x. And we're going to just use the a part. So that's when x equals pi over 6. And we're looking for, it says in the instructions, find y prime. So that's what we're looking for. And it's also given to us that x prime is equal to 2. Two centimeters per second. Alright, so let's go ahead and take the derivative of this function here. So if I take a quick derivative, I get y prime is equal to, now remember, chain rule, the outside function here is sine. What is the derivative of sine? Cosine of x. Very good. But we also have to now multiply it by the derivative of the inside function, which traditionally was 1 because that was with respect to x. But this time it's a related rate problem, so it's with respect to t, and it's going to be x prime. So if I clean this up, in other words, move this x prime to the front like we traditionally do, we have x prime cosine of x. All we need to do now is plug in everything. So we have y prime is equal to x prime, which is 2, times cosine of pi over 6. Or in other words, that's the same thing as saying 2. Let's see, cosine of pi over 6. Pi over 6 is 30 degrees. The cosine is the x-coordinate, so the x-coordinate of 30 degrees on the unit circle is going to be radical 3 over 2. And what happens to the 2's? They cancel, that's right. Leaving you just with radical 3, but let's not forget units. And it's going to be a rate. So we will have the only thing which we see here, centimeters per second. And that's our answer. Okay, now we are going to move to number 15. So if you take a look at number 15 right quick. Alright, so if we read number 15 together, it says, the radius r of a circle is increasing at a rate of 3 centimeters per minute. Find the rates of change of the area when A, r equals 6 centimeters, and B, r equals 24 centimeters. Again, I'm just going to do the A part for this because if you can do the A part, you most likely can do the B part. So, the first thing we need to figure out is, first of all, write all of the information that is given to us. It says the radius r of a circle is increasing at a rate of 3 centimeters per minute. Let me repeat that. The radius r of a circle is increasing at a rate of 3 centimeters per minute. So what does that mean? That means that r prime is equal to 3 centimeters per minute. Remember, keyword here is rate. Find the rates of change of the area. That's another keyword. Find the rates of change of the area. Find the rates of change of the area. So in other words, I'm looking for A prime when r equals 6 centimeters. When r equals 6 centimeters. Okay, well, we have to figure out what formula we will be needing. In other words, kind of figure out what shape we're discussing. And in the story, it says it right there in the first part of your sentence. The radius r of a circle. So here we must be using the area formula of a circle, which is A equals pi r squared. All right, let's go ahead and implicit differentiate both sides. So we get A prime is equal to, remember, pi is considered to be a constant, so I'm just going to go ahead and bring it down. The power, which is 2, times your expression to the 1 less, which is just r, times the derivative of what's being raised to the power, which is r prime. So if I clean this up and write it more traditional, it's going to be 2 pi r prime. All right. Is the variable that we are looking for already isolated? So we're looking for A prime. Is it already by itself? It is. So all we have to do now is substitute. So let's do that. So we have A prime is equal to 2 times pi times r, which was or is 6, times r prime, which is 3. So we multiply 3 times 2, that's 6, times 6, that's 36, times pi, so that gives us 36 pi. And that is a rate, so it's going to be Area is usually in what? Squared units, so it's going to be, in this case, our unit will be centimeters squared over some kind of time, which in the story is minute. And that's our answer. For number 15. Okay, let's jump to number 18. And again, we are probably going to use just do 18A. So let's clear this off. All right, number 18 says the radius r of a sphere is increasing at a rate of 2 inches per minute. The A part says, find the rate of change of the volume when r equals 6 inches and r equals 24 inches. So for this one, I'm just going to do the first part, which says r equals 6 inches. So let's write down all of the information that is given to us. It says the radius r of a sphere is increasing at a rate of 2 inches per minute. So that means that r prime is equal to 2 inches per minute. Okay. The next piece of given info, it says find the rate of change of the volume. So we're going to be looking for V prime when r equals 6 inches. So when r is equal to 6 inches. Alright, so we have to figure out what equation we are going to use. And in this case, it's pretty self-explanatory. We are going to use the volume of a sphere. Alright, so the volume of a sphere is 4/3 pi r cubed. Alright, so we have to differentiate both sides. So let's do that. So we have V prime is equal to, remember that 4/3 is considered to be a constant, so I'm just going to go ahead and keep it. So 4/3 pi, those are constants. Now, the power times your expression to the one less, so that's going to be r squared, times the derivative of what's being raised to the power, which is r prime. Alright, so what happens to my 3's? My 3's cancel each other. So I am really left with 4 pi r squared r prime. Alright, so I need to look for V prime. It's already isolated, so we don't need to do any moving around. It's already good to go. So your next bet is to go ahead and substitute. So I have V prime is equal to 4 pi times r squared. So r is 6. If I square that 6, I get 36 times r prime, which gives me 2 from the story. Okay, so now all I need to do is just multiply straight through. 4 times 36 times 2, and then don't forget that pi. So that gives me 288. Pi. and it's a rate, so it's